Have you ever wanted to make your own airliner? Have you wondered what sort of propulsion your airliner should have? Well, if your answer to these questions is yes, then you have come to the right place because I can help. Today I'll take you through the various types of aircraft engines and how they work to help you make the right choice when creating your airliner. This is the earliest form of aircraft propulsion, and whilst mechanically more complicated than a jet engine, it is also the cheapest to overall purchase and maintain for your aircraft. Despite having more moving parts and in theory being more complex than the alternative engine types, piston engines are relatively easy and inexpensive to service. Many mechanics understand the inner workings of a piston engine, and the parts are quite common and easy to find. All piston engines are fundamentally the same and can generally take more of a beating than a jet. The peak operating performance of a piston engine is limited to certain altitudes, and they have lower power-to-weight ratio than a jet. They are also less efficient at high speeds and high altitudes, and would therefore make for a poor long-haul passenger aircraft. If pushed to the absolute limits, with superchargers extracting every last morsel of power, and when stuck on high-performance aircraft, a piston prop can reach an altitude of 60,000 feet, as demonstrated by the Grob Strato 2C, and speeds of 528 miles per hour, which were achieved by a Grumman F8F Bearcat. Whilst this exceeds the performance of some jets, it must be noted that these are extreme examples, which are easily dethroned by the extremes of jet aircraft. So, to summarise, the piston prop: cheap, readily available parts, efficient for small and light aircraft, and at lower altitudes and speeds, simple to operate, and the perfect choice for a small, private aircraft used for recreational purposes. And when more enhanced performance is required, a piston prop is certainly a viable option, and up to the job. The limitations are obvious, however, with poor fuel efficiency at high speeds and altitudes, plenty of noise and vibration, and more moving parts prone to failure. As well as a lower power-to-weight ratio, there is a reason that piston props have been phased out of the commercial aviation sector. The classic jet engine, a tube of many spinny things shooting out hot, high-velocity air. At first it seems almost too good to be true. A jet engine is, in theory, far more simple than a piston engine, and almost efficient enough to be a perpetual motion machine once you've got it going, without even needing to hide any batteries in it. The inertia of the turbine keeps it rotating, which pulls more air into the compressor stages, which is then compressed and heated and used to rotate the turbine in a continuous cycle. All you need is a constant flow of air into the engine and some fuel, and you're good to go. There is no energy wasted converting reciprocating motion of pistons into rotation. But this simple iteration of a jet engine is far from perfect. A basic turbojet burns a lot of fuel and is still incredibly loud. Most of that noise comes from the high velocity exhaust gases exiting the engine, and whilst it can achieve higher altitudes and speeds more easily than a piston engine, that does come at the cost of burning lots of fuel, even at lower speeds and altitudes. In other words, there is an improvement in efficiency in certain scenarios when compared to a piston prop, and it certainly has a higher power-to-weight ratio, which leads to better overall performance, as well as having less moving parts and therefore less chances of something going wrong. But this all comes with a few caveats. Whilst a jet is simpler than a piston engine, they are also more expensive to produce. The parts must be specially designed to withstand higher temperatures and pressures, which means that they must be made of more expensive aerospace-grade materials, such as titanium and a variety of alloys. And they also have a much lower tolerance for imperfections. In other words, a jet engine is probably beyond the expertise of your local mechanic. This means that if you want a jet engine, it's going to cost you. But for commercial purposes, this initial cost could very well be worthwhile. Well, it would have been worthwhile, until Pure jet engines have been mostly phased out by now. This is because we now have better choices of jet for our airliners. The bypass turbofan engine. In essence, you take the core jet engine, surround it with a larger casing, add a big old fan on the front, and now you've got yourself two separate airflows powered by the same turbine shaft. This bypass air envelops the exhaust of the jet engine, reducing the noise, improving the fuel efficiency, and adding to the overall thrust of the engine. More recent iterations of the turbofan have begun to introduce gearing to reduce the speed of the fan and improve efficiency further. Fast military jets nowadays also typically use low bypass turbofans with afterburners. And new airliners are using engines with very high bypass ratios, which basically means that they have a large diameter fan and most of their thrust comes from the air going around the core jet engine. This is something you do if you want to maximize efficiency and reduce noise. So what are the downsides? Well, there aren't any, really. Yes, they have a higher fuel consumption than a piston engine, but that doesn't matter since they produce way more power than a piston engine and are more reliable than a piston engine and far more efficient. So it seems that we have found our perfect engine then. Well, for most scenarios anyway. Maybe you don't care about speed so much, and you don't mind a little extra noise and vibration. If that's the case, there may be something even better in store for you. That's right, it's the Turboprop. At a very basic level, a turboprop is just a jet engine which drives a propeller instead of a big fan, and uses the propeller to generate thrust instead of the jet exhaust. Cut to the chase, this engine type is very, very efficient, more efficient than a turbofan, with the small caveat of having to sacrifice speed and altitude somewhat. They also add a few more complications when compared to a basic turbofan, such as gearing and variable pitch propellers. Also, if you've ever travelled with a turboprop, you may recall that the ride is not so comfortable due to the noise and vibration of the damn things. But what if you want to go fast? Like, really fast? To get to speed, you'd use a turbojet, of course, or a low bypass turbofan. But once you've reached those supersonic speeds, the efficiency of these engines starts to drop off a little, and this is where new avenues for propulsion begin to open up. Now, if you thought we couldn't get any more simple than a turbofan or a turbojet, that's where you're wrong. It turns out we can make engines even simpler than a tube with a bunch of spinny things. How about a tube with no spinny things? It's just a tube. First, we'll look at the Ramjet. You can think of this engine as achieving propulsion by literally ramming into the air to compress it and ignite it. Its shape alone is all that's needed to compress the incoming air enough to use it for thrust. This engine type works best at supersonic speeds of up to Mach 5, which is why you'd need some other form of propulsion to actually get it up to a sufficient speed. Once at supersonic speeds, however, this engine has incredible efficiency and quite literally no moving parts. But what if you want to go even faster and higher? That's where the scramjet comes in. The scramjet uses supersonic airflow as opposed to subsonic airflow in combustion, which means that it only really works at hypersonic speeds and it's quite difficult to maintain, and it also uses liquid hydrogen as fuel and needs an oxidizer. So these are clearly very niche engines, only really used in cruise missiles and really fast experimental jets. And they're very difficult to manage and have very specific operating parameters. So there you go, that's it. That's your basic guide to the main propulsion types for your airliner. Pick wisely. My job depends on it.